Hello everyone. So today we are going to talk about the arterial supply of the kidney. Now before going into the arterial supply of the kidney, we should understand a few of the basic things about the kidney. Now this is a cross section of a kidney and we can see certain structures over here. But before going into the explanation of these structures, we should understand one thing, that the kidney is mainly made up of two systems. One system is filtering out the blood and the other system is collecting that ultrafiltrate and taking it out of the body in the form of urine. So when we take a cross section, we first find the picture like this. So in this picture, we see a dilated area of the ureter, which is called a pelvis, going inside the kidney. Now if we can just remove this pelvis out, then we will find that this kidney is actually having a hollow area, which is called a renal sinus. So this renal sinus is actually getting occupied by the pelvis of the kidney, pelvis of the ureter, the pelvis of the ureter, which is nothing but the dilated part of the ureter. So the pelvis is situated inside this renal sinus. Now this pelvis is getting divided into 2 or 3 large branches called the major calyx. So this is one major calyx, this is another major calyx, and this is another major calyx. So here we have drawn 3 major calyces. Calyx is the singular term and calycis is the plural term. So the pelvis will divide into 2 or 3 large branches called the major calyces. Now these major calyces will further divide into smaller branches called the minor calyces. So depending upon the branches, a kidney can have anywhere from 8 to 12 minor calyces. Now these minor calyces will be situated underneath an inverted triangle, which is called a pyramid. This pyramid is mainly made up of striations. Okay, longitudinal parallel lines coming towards the tip or the apex of the triangle. The triangle has its base towards the cortex of the kidney, and the tip or the apex of the triangle, which is also called the renal papilla, comes and sluggles into the minor calyces. Okay, it hangs over the minor calyces. So this is also not the filtering part. This is still, we are talking about the collecting part. Okay, and these striations that we are referring to as are nothing but the collecting ducts. So the nephron will have a, if you remember, a nephron will have a Bowman's capsule, then it will have a distal convoluted tubule, then it will have a small loop of Henle, then you will have a it will have a proximal convoluted tubule, then it will have a loop of Henle, then it will have a distal convoluted tubule, and then it will go into the collecting tubule. So this collecting duct, these collecting ducts, 2 or 3 collecting ducts will come together and it will form the collecting tubule, and these collecting tubules come towards the apex of the papilla, apex of the renal pyramid, and they come together to form a bigger duct of Bellini, and this duct of Bellini actually opens at the bottom of the papilla, and through which the urine will be poured into the minor calyces. Now this whole system can be compared to the filter. So when we need to have a glass of water, what we do, we take a glass and we go to the filter in our house. So we put the glass underneath the tap and we turn on the tap. The water flows inside the cup or the glass and we take it. Okay, now the filter has got the filtration process somewhere else. So the filter will have some system within itself that will filter out the water, and the water will be then poured into the glass via the tap, and the glass will be held underneath the tap. So here also the filtration of the kidneys, filtration by the kidneys is done somewhere here in the cortical parts by the nephrons, this structure, right, this structure. Okay, and then the urine will be collected here and it will go through this medullary rays into the renal pyramid, and then through the duct of Bellini, which will be acting as a tap, it will be poured into the minor calyces, which will be acting as the glass. So just like we held the glass underneath the tap of filter, the minor calyces are present underneath the papilla or the apex of the pyramid, and the urine will be poured into this minor calyces through the ducts of Bellini. Okay, now the next thing that we need to understand is the lobes of a kidney. So the kidney has been divided into multiple lobes, and these lobes are nothing but each pyramid with the overlying cortical area is forming the lobe. So this is a pyramid and this is the overhanging cortical area. It also contains a little bit of the surrounding tissue. Okay, this is also containing the bit of the surrounding tissue. As you can see here, this is a portion of the surrounding tissue that is adjacent to the pyramid. So the pyramid along with the overhanging area of the cortex and a little bit of the surrounding tissue will form the lobes. There are about 8 to 12 pyramids, so there will be about 8 to 12 lobes, and at the same time there will be 8 to 12 minor calyces, because the number of pyramids will be the same as that of the number of the minor calyces. So a renal lobe will be therefore each pyramid with an overlying area of the cortex and a little bit of the surrounding tissue will be forming the renal lobe. Now within this renal lobe we have got its smaller portion, which is called the lobules. So the lobules is nothing but this medullary ray and surrounding area of the cortex. So this medullary ray is nothing but the collecting duct, and the surrounding area of the cortex will have nothing but the nephrons that will be opening into this collecting duct. So if we consider that, then this becomes a renal lobule. This portion becomes a renal lobule, at the center of which will be a medullary ray, and this medullary ray is nothing but a collecting duct, and the surrounding cortex will be having the multiple nephrons that will be opening into this one particular collecting duct. So a particular collecting duct will have multiple nephrons like this. Okay, this is one, then you can have another one like this, then another one like this. So a medullary ray with the corresponding nephrons draining into it, which is present in the surrounding cortex of this medullary ray, will form a renal lobule. So a renal lobe is pyramid with overlying area of the cortex and a little bit of tissue surrounding it will form the lobe, and the lobule will be the medullary ray in the center and a little bit of cortex surrounding it, which will contain the nephrons that will be draining into this particular medullary ray. Okay, so with this idea in our hands, let us move forward to the blood supply of the kidney proper. Okay, now the kidney is a very vascular organ. It receives a lot of blood from the heart, and it receives the blood from the aorta. Okay, the aorta, the abdominal aorta, will be carrying the blood from the heart to the abdominal organs, and they will divide into the renal arteries. So there are two kidneys, so there are two renal arteries, right renal artery and the left renal artery. They are the direct branches of the abdominal aorta. They branch off at 90 degrees from the aorta, and they go behind the renal vein. The renal vein drains into the inferior vena cava and is lying anteriorly to the renal artery. So once the renal artery goes through the hilum, now hilum is an area of the organ through which structures go in and come out. In this case, the renal artery goes in, the nerves will go in, the lymphatics will come out, the vein will come out, and the ureter will also come out. Okay, so basically it depends upon the flow of the material that is being contained within these tubes. Okay, so if blood is arterial blood is going in, venous blood is coming out, so the veins are coming out and the artery is going in. So once the renal artery goes inside the kidney through the hilum, it divides into multiple small segments. So these segments are these arteries divide according to the segments of the kidney. So the kidney is divided into some segments called the arterial segments of the kidney, and these segments are important because these segments help the surgeons to carry out surgeries like partial nephrectomy in a way that the other portions or parts of the kidney is not affected. So these segments of the kidney are basically areas of the kidney that are being supplied by one branch of the renal artery, which is called a segmental artery. These segmental arteries are end arteries, and they do not communicate with they do not give a branch to other segments. So therefore, if there is a problem with one segment of the kidney, it can be easily removed surgically without hampering or without affecting the other segments. Okay, so there are 5 segments. There are 5 segments as can be visible through this diagram. So there are 5 segments: the apical, the superior or the upper, the middle, and the inferior segment. Okay, so these segments are divided according to the blood supply. So the renal artery first comes and it first divides into the anterior and the posterior branch, and subsequently these branches divide into apical, superior, middle, and inferior segmental arteries, and also the posterior segmental arteries. So the apical segment consists of the medial side and the anterior part of the superior pole. So this is the anterior view of the kidney. So this is the anterior view of the kidney. So the apical part consists of the medial side and the anterior part of the superior pole. So this is the superior pole, and this is the anterior view. So this is the apical segment. The upper or the superior segment includes the remainder of the upper pole and the upper part of the anterior aspect. The middle one includes lower part of the anterior aspect and lies between the upper and the lower segments. So this is the inferior segment or the lower segment. So the upper, in between the upper and the lower segment, will be the middle segment. The lower segment or the inferior segment consists of the whole of the lower pole. So this whole of the lower pole is mainly the inferior or the lower segment. The posterior segment consists of the whole of the posterior aspect of the kidney. So this is the posterior view of the kidney. So it will be consisting of the whole of the posterior aspect of the kidney between the apical and the lower segments. Between the apical and the lower segments. Okay. So these are the 5, and this is the lateral view also. Again, the upper pole will be taken up by the apical segment. The lower pole will be taken up by the inferior segment or the lower segment, and in between there will be a portion on the lateral side that will be for the posterior segment, and on the posterior surface. This is the lateral surface, so this will be the posterior aspect of the lateral surface. So it will be posterior segment, and on the anterior surface we will have the superior and the middle dividing the middle portion of the lateral surface. Okay. So these segments were first proposed by Graves in 1954, and it was based on the distribution of the major branches of the renal artery in each of the kidneys. Okay. So there is one more thing that we should know about the junction between the areas. So we have already told you that the renal artery goes inside the hilum and it divides into anterior and posterior divisions before getting divided further into the segmental arteries. So the junction between the areas supplied by the anterior and the posterior branches or divisions of the renal artery is called Broddel's line. So I have written the bloodless line of Brodel. Is it visible? Yeah, bloodless line of Brodel. So basically what happens, this is the line or the area that is present between the areas supplied by the anterior and the posterior divisions of the renal artery. Okay, it is on the posterior aspect of the kidney at the junction of the middle 2/3 and the lateral 1/3. Okay, it is in the posterior aspect of the kidney at the junction of the medial 2/3 and the lateral 1/3. Okay, so this is the bloodless line of Brodel. So basically it is an area of relative avascularity or less vascularity between the areas supplied by the anterior and the posterior divisions of the renal artery. Okay, now let us then talk about the different branches. Now till now we have understood that the renal artery, which is getting branched from the aorta at 90 degrees with the aorta, and it is going posterior to the renal vein, then it is coming into the hilum. Into hilum it is first dividing into an anterior division and posterior division, and then it is getting divided into segments that will be supplying the segments of 5 different segments of the kidney, and at this junction these branches are called the segmental arteries. Now these segmental arteries then go towards the pyramids. So we have this diagram here. We have this diagram here where this is the renal sinus and this is the pelvis. So this is basically a part of the hilum. So the renal artery will come here, then it will divide into anterior and posterior part, and then it will divide into segments: anterior, posterior, medial, superior, inferior, like that, and then they will go towards the pyramids. they will go towards the pyramids, and they will divide, and go in between two lobes. So this is one lobe, that is, we talked about the lobe a little while ago. A lobe is nothing but a part of the is nothing but a pyramid, along with the overhanging cortex and a little bit of area of the cortex surrounding the pyramid. So pyramid, area surrounding it, and cortex overhanging it. So this portion is the cortex. So this is the lobe. So since this is one lobe and this is one lobe, this artery is getting branched, and this branch is running between two lobes. So it becomes an interlobar artery. Okay. So this interlobar artery goes towards the cortex, and when it reaches the base of the pyramid, it divides dichotomously. So it will go like this, then it will divide dichotomously, and then it will run into the cortex. And at this junction, this is called the arcuate artery. So this is an arcuate artery, this is an arcuate artery. Two subsequent two adjacent arcuate arteries, they never give branches to each other, or they never anastomose. Rather, what they do, they give branches, parallel branches, that are going towards the kidney, to the cortex of the kidney. So these are smaller branches that will be going towards the cortex of the kidney, and these branches will basically go through the two adjacent lobules. Now we have already talked about the lobule. It is nothing but a lobule is an area of the kidney that has got a medullary ray at the center, with a surrounding area of the cortex, which usually has multiple nephrons that will be draining into that central medullary ray. Okay, so that will form a lobule. So in between these lobules, there are multiple lobules. So in between these lobules, the arcuate artery will give off branches. So the arcuate artery is going like this. So this, let me just refocus a little bit. Okay, hopefully this will be visible to you. So the arcuate artery will come, so this interlobar artery will come like this, then the arcuate artery will go like this, and then it will give off interlobular artery that will be going in between the lobes, that will be going in between two lobes. Okay, that will be going in between two lobes. So this is one lobe, this is another lobe, and this artery is going in between these two lobes. So this is another artery. So we have one lobe here, so there will be another lobe here. So since not lobe, lobules, so they will be going in between two lobules, and at this junction they are called the interlobular artery. Now when this, I'll redraw again, when this interlobar artery divides into arcuate arteries and gives off interlobular arteries. Okay, now what is this interlobular artery doing? This interlobular artery is present. I'm just making a bigger picture of the smaller segment. So this interlobular artery will be present where? It will be present between two lobules. Okay, so let me put green for the collecting duct. So this is a medullary ray or the collecting duct. So what will be happening in that? There will be multiple nephrons opening in. So this forms a lobule. We know that a nephron is a structure like this. Okay, so what is present here? This is the Bowman's capsule. So what is present here? Here we have got the glomerulus, and this glomerulus is formed by what? Efferent arterioles coming in, forming the glomerulus, and efferent arterioles going out. So this efferent arteriole, this one, will be given off by the interlobular artery. So this interlobular artery will give off an efferent arteriole, which will form a glomerulus, and efferent arteriole will come out. And by the side of this glomerulus, we'll have a This is a graphical representation. We'll have a Bowman's capsule under nephron, and this is what? This is what? This is a lobule. So this is a lobule. So this interlobular artery will give an branch which will form the afferent arteriole, and it will form the glomerulus for the Bowman's capsule, and on the other end you'll have the afferent arterioles coming out. So this is basically a capillary system. Okay, so this is basically a capillary system. So this is in nutshell about the arteries and the arterial supply of the kidney. So recapitulating with the help of a flow chart. So first we have the blood coming out of the heart via the aorta. Now this aorta is the abdominal aorta. It will give off renal artery. Okay, it will give off renal artery. I'm just holding this one. So it will give off renal artery, which will be present behind the or posterior to the renal vein. It will go inside the kidney. First it will divide into anterior and posterior divisions, and then it will be divided into segmental arteries, where it will be supplying the segments of the kidney. Then these segmental arteries will approach the lobes, and they will send off branches in between the lobes, forming the interlobar artery. Then this interlobar artery will reach the base of the pyramid, and then they will divide dichotomously to form the arcuate artery. So this is an arcuate artery, this is an arcuate artery. From the arcuate artery, they will give off smaller branches that will go between two lobules of a kidney. So it will be called the interlobular artery. From the interlobular artery, as we have drawn here, from the interlobular artery, it will give off a branch which is called the smaller branch, which is called the afferent arteriole. So it will give off the afferent arteriole, and it will form the glomerulus, and from the other end of the glomerulus we have the efferent arteriole. Okay, so this is basically the blood supply of the kidney, which is a very important topic and a very interesting one at that too. So hopefully you have understood the basic arrangement of the renal arterial system, and we will come back to you with a different topic. If you have any doubts, you can ask me. Okay, so thank you for your listening, and good night.